Welcome to Border Problems Part 2. In this video, I'm going to go through problems 4 and 5. Keep the videos a little bit shorter because that first one I know was lengthy. But if you have any questions on these, you can get to hopefully fast forward to where you need to be. So I'm going to jump right into it. We've got a rectangular plot of ground measuring 12 by 20. Surrounded by a sidewalk of uniform width. The area of the sidewalk is 68 square meters. All right. Take this information, turn it into a picture. We have a rectangular plot of ground. It is 12 meters. Actually, I'm going to go ahead and make this a little bit more accurate. It is 12 meters by 20 meters. Surrounded by a sidewalk of uniform width. Okay. So this is the part that is all uniform, even if it doesn't look it with my picture. That's okay. I'm going to go ahead and label everything X here. Okay. I'm going to use all this information, and I am going to label the outside rectangle, the big rectangle. So its longest edge across the bottom here is 20 plus 2x. Its height is going to be 12 plus 2x. One other piece of information that we're told, we know that the area of the sidewalk is 68 square meters. One other piece that I can add here is that the area of the rectangular plot of ground, if that's 12 by 20, that should be, what, 240? That sounds right to me. But since my brain is sometimes Swiss cheese, I just double-checked it in my calculator. All right. So what I'm going to do now is use these pieces of information, the 240 for the rectangular plot of ground and the 68 for the sidewalk, and create an equation based off of those. So I'm going to say that the big rectangle, so 20 plus 2x and 12 plus 2x, is equal to the little rectangle plus the sidewalk. Okay? All right. I'm going to go ahead and multiply this mess out. So let's see, that's 240. Let's see what else I have here. So plus, that does not sound right. I just typed in something in my calculator wrong, and it gave me a very wrong answer. Oh, that sounds much better. So 64x plus 4x squared is equal to, I'm actually going to just leave that as 240 plus 68. The method to the madness is the 240 on either side will cancel. So that's kind of nice. A little rearranging here. So 4x squared plus 64x minus 68 is equal to 0. I'm pretty sure everything divides by 4. It does. All right, so x squared plus 16x minus 17 is equal to 0. Take a moment and factor. Negative 17 and positive 17, negative 1. Okay. So that's going to get me x is equal to negative 17 or x is equal to 1. One of those answers gets to get thrown out because it does not make any sense to talk about a sidewalk that is measuring negative 17 meters. So that one does not make any sense. What is the uniform width of the walk? 1 meter. That's it then. Okay, so again, annotate it, draw the pretty picture, fill in the information in the pretty picture, and then from this, build an equation that makes sense. Okay? All right, let's see what we've got here for number 5. Well, I got some space here to work, which is nice. All right. The floor of a room, 20 meters wide and 30 meters long, is being waxed starting in the center. 1/3 of the room has been waxed, leaving an unwaxed strip of uniform width along the edge. All right. So we have a room. Okay, 20 by 30. And it's being waxed starting in the center of the room. So this area is the part that's gotten waxed already. So inside the room, on the floor here, I'm going to go ahead and mark my little waxed portion, leaving an unwaxed strip of uniform width around the edge. Okay. This is another place where you want to be careful that you're not making the 20 by 30 the littler rectangle, and then the outside part being the waxed part. That would be like waxing the walls, possibly waxing, the doorway. Not what you want to do. Okay. So let's cut into the little rectangle here. Let's see. This would be 20 minus 2x. Let's actually get the 2 in there. And this is 30 minus 2x. Okay. I know, let's see what I know. I know that this is 1/3 waxed, and this is 2/3 unwaxed. Okay. So let's see. If we just focus on the little rectangle, we have 1/3 of the room. Well, the room is 20 by 30. Helps if I actually put 20 and a 30 there. There we go. And this is equal to the dimensions that we have. So 20 minus 2x times 30 minus 2x. Okay? Okay. Let's see what we get here. If I do 1/3 times 30 times 20, so this turns into 200. 20 times 30 should be 600. 40, 60. I think that's minus 100x. I feel like I want to double check that just to make sure. That is. And then plus 4x squared. Okay. Little rearranging here to make the world a little better place for me to solve this problem. That would be plus 400. Okay. So divide everything by 4. So x squared minus 25x plus 100. Okay. So quick factoring here. Let's see, minus 20 and minus 5. That multiplies correctly, that adds correctly. Okay. Okay, this is working out all right. So we're going to get x equals 20 and x equals 5. Positive values. Awesome. But one of them does not make sense. If your room is only 20 meters wide, it is not possible to have a strip on either side that is 20 meters that's not waxed. That does not work, okay? You can either logic through it that way or check, right? Put it in here. 20 minus 2 times 20. 2 times 20 is 40. 20 minus 40 is negative. That does not make sense. It doesn't even matter if the other side would work. As soon as you get a negative dimension, when we're talking about length or width, any kind of measurement that you would take with distance, you don't have a negative measurement there. So that 20 we can cancel out. That does not make any sense. However, we can say that the width of the strip that is unwaxed is 5 meters. All right. So I'm going to go ahead and close this video off. I will make a couple more videos for the other problems on the page because, again, I know these problems are not the easiest because they do not follow one specific pattern each time. As always, if you have any questions, let me know.